Esto es Atmósfera sin Fronteras, reporte desde el ICAyC. En nuestro día a día, cuando salimos al trabajo, a la escuela, a hacer ejercicio o alguna otra actividad, nuestro ambiente puede estar determinado por el cielo, y estar despejado o por el contrario, tener nubes. Sin embargo, se han vuelto parte de nuestra cotidianidad que no nos detenemos a preguntarnos cómo es que se forman las nubes o cuál es su importancia. El doctor João Teixeira, en el seminario Turbulence, Clouds and Climate Models, explica que una nube es el producto de interacciones complicadas de la turbulencia convectiva húmeda con circulaciones a mayor escala, radiación y microfísica. Es decir, que las nubes están ligadas a la convección, movimientos verticales de pequeña escala de aire cálido, y ello hace difícil representarlas en los modelos climáticos, pues se trata de un problema de convección y turbulencia. Para entender esto, el Dr. João nos explica cómo funciona un modelo climático.
So, to summarize that, so there are equations that have been developed from the last 200 years. Those are differential equations that have been developed by scientists for a long time that describe how the atmosphere works. So how much wind you have, what is the pressure, what is the temperature. And those equations that exist for a long time only started to be resolved because they're so complicated that they could only start to be solved when computers arrived. But the computers only arrived after the Second World War. So it's only after the Second World War that these very complicated equations could be solved. And of course, as these computers get better and better and faster, you can get better climate models. Climate models are basically based on equations that were developed for the last 200 years that describe things like temperature, wind, pressure, and they basically solve in computers because they're so difficult to solve in pen and paper. That's what a climate model is. A climate model or a weather model are very similar in the atmosphere, except the weather model, you just do a 10-day forecast. With the climate model, you have to have the atmosphere and the oceans, and then you do a 100-year forecast. So it's a longer process.
El investigador destaca que es necesario desarrollar ecuaciones para representar la dinámica de variables estadísticas de turbulencia y convección, o dicho de otra forma, la parametrización de turbulencia y convección. La parametrización de la mezcla turbulenta, convección y nubes en modelos atmosféricos globales resulta un gran desafío en la investigación meteorológica y climática. Al respecto, el investigador comenta:
It's basically a simple model of how the atmosphere behaves in a statistical way. So, because we can't solve the equations for every, like if you look at the trees, you can see them oscillating a little bit, changing a little bit because there's wind and there's turbulence. But you don't need to know, if you want to do weather prediction or climate prediction, you don't need to know exactly what's happening around that tree, right? What you need to know is sort of what is the mean wind in Mexico City. But when you look at the weather forecast and say, the wind is, 10 kilometers an hour, that's sort of an average of the winds in a big region, right? And so a parameterization is a simple model that has equations for properties like that, like the mean or the variance of the wind or the temperature. So it's just a simple model that tries to describe the statistics of the dynamics of the atmosphere.
El papel de las nubes en los modelos climáticos es de suma importancia, puesto que se pueden ver afectados por anomalías de la temperatura global de superficie.
So clouds play a fundamental role in climate. So even small changes in clouds can make a big difference in sort of the energy balance of the Earth. So you could sort of summarize the climate change problem is about how much energy is coming to the planet from the sun versus how much energy is leaving the planet through what we call thermal radiation. And the clouds play a big role because clouds are one of the things that they do is that they're very effective reflectors. They reflect the solar radiation you can see that when you're flying on an airplane sometimes and it's full of clouds and you can see the sun hitting the cloud and it almost blinds you, right? Because it's so intense. So the clouds are very good at reflecting the radiation from the sun. So the clouds overall cool the planet, and in the context of climate change, very small changes of clouds could make climate change much worse, could actually make climate change not so much of a problem. So predicting what's going to happen to clouds is very, very, very important for climate change prediction. But we still don't know exactly what's going to happen to the clouds.
Algunos tipos de nubes pueden reflejar más luz solar, enfriando a la superficie, o pueden tener el efecto contrario al absorber la radiación de onda larga y calentar la superficie, por lo que no solo significan una mezcla de gases en el cielo, sino que mantienen una estrecha relación con el balance radiativo del planeta y con el calentamiento global. Es por ende que se requieren más investigaciones y estudios que representen adecuadamente la complejidad de las nubes en los modelos climáticos. Si quieres ver el seminario completo, puedes hacerlo en nuestra página www.atmosfera.unam.mx o en nuestro canal de YouTube. Y no olvides seguirnos en nuestras redes sociales buscando ICAyC-UNAM.